Swayam Prabha. Digital India. Educated India.
A very good morning to all of you. This is the same experiment, the continuation of the experiment which we were doing in the earlier module in a different lab, where we were talking about laser etching of PMMA sheets. The idea there was to be able to use that as a mold so that you could develop a device, and the device could microfluidically operate and do various testing or calibrations for different processes at the microscopic length scale. So, here in this module, what I would like to demonstrate today is basically work on the next step of replicating the shape or the feature that had been produced by laser etching technique, and the replication would be like a micro casting. So, therefore, you have to use a soft polymeric material. In our case, we will use material called polydimethylsiloxane, PDMS, and this PDMS is nothing but a silicone rubber which is otherwise commercially available into two different into two different forms. One of the components is actually a curing agent, another is a silicone rubber, and you mix both of these components together in a certain ratio to obtain the requisite bond strength, and the curing agent essentially helps the PDMS to develop cross bonding, and eventually it results in a rubber like membrane which comes out. Okay. So, if this is poured on a small laser etched surface, the surface kind of gets replicated and the negative of that is created onto the surface of the PDMS. So, I would just like to recall what we did in the last module, where we actually made a device like this using CO2 laser processes on PMMA, and the etching which happened therein resulted in this kind of a feature being imprinted on this surface of depth about close to 14 or 15 microns and various widths or various dimensions of the different parts that you can see on the central chamber, the chambers which are on the sides, etc. So, I am going to actually take a box where this is a commercially available plastic box, and this is for the purpose of pouring the PDMS and containing it or confining it over the mold surface. So, whatever you saw here, this particular chip that had been formulated, I am going to first sort of paste this on the top of this box at the center and make it immobile, and then use that as a casting platform, as a mold platform for microcasting the PDMS. So, I am going to first try to fix this using double sided tape over this box, and before doing that you ensure that you have another identical box here, so that whatever amount of PDMS is needed on the top of this mold box can be calibrated using this other spare box of identically same nature. These are very easily commercially available in the market. Okay. So, now what I am going to do is to take double sided tape like this. Interestingly, the double sided tape commercially available in the market comes in this form, where one of the sides has a yellow covering on the top and the other side also has adhesive. So, basically the adhesive side is lifted up like this, and you can measure how much you need for completing the or cover the whole mold surface and try to fix it. So, using normal shear pliers, I want to take small measurement here like this to be able to kind of estimate how much length is needed to cover the whole surface, and I am going to cut a piece of this length all the way up to here, so that it can cover half the surface of this feature very well. Okay. So, I am going to actually now place this feature almost halfway through in this particular tape, like you can see here. Okay. So, the other half can have another piece which I will cut out by doing the same kind of size measurements, and what I am actually going to do is try to cover the whole base of this mold in a similar manner. Okay. So that, and one thing you have to really ensure is that you make it butt tightly to the other tape, so that it is one continuity. Okay. You can see from the back, there is no gap between the two tapes that you have put, and then on the top surface there is some projection which is in an outwardly manner, and I am going to just shear that off so that it becomes of the same size as the mold. Okay. So, we will do this shearing action. See roughly now the size and shape of this double sided tape is such that it is covering the entire lower portion of the mold box, and the etched feature is available somewhere on the top surface, which you need to micro replicate. Okay. One has to be really careful about which side you are pasting, because this feature itself is very small. The only way to feel it is to either rub your nail over it and see if it produces a scratching sound because of the laser etching which has happened in this area, or if the features are too small, just try to ensure with your hand whether there is a feature of a certain depth and the planarity of the surface is not uniform, and that goes on the top side, the other plane surface or planar surface goes on the bottom side. So, I just need to pull this tape off from the lower surface, exposing the other side of the tape, okay, like this, similarly like this, and you are left with the adhesive part now on the lower side, which you want to go ahead and paste on the top of this particular box, right about in the center of the box as this. Okay. So, this is how it now looks, and you can see that because of the tape it does not go anywhere, and when you pour something which is liquid in it, there is always bound forces through which the mold might come up unless it has been fixed. So, this we did for ensuring that the mold does not float up because of the buoyancy of the liquid. In any event, PDMS is a highly viscous thick liquid which will have to offer more buoyant forces, and we need to somehow be able to hold this mold onto the place so that the PDMS can go on the top without making it to lift the mold off because of buoyant effects. So, I am now going to go ahead and make the PDMS solution. As I told you, there are two parts of the PDMS in which it normally comes. This particular PDMS is from a company called Doconic in Midland, and the brand name is known as Silgard 184. So, you have two components. One is a Celgard 184 silicone rubber, which comes in this tube, and then this curing agent. And I'm going to now sort of go ahead and mix these two in a manner so that the PDMS comes all the way to the top of the box here, so it can actually cover what is there on this particular mold surface. So for that we need a chemical balance like this, and we'll just try to first measure the amount ratiometrically through weights, and then we will just do 10:1, 10 parts of the silicone rubber and 1 part of the curing agent, and then mix properly using a pipetter so that it can uniformly disperse. The two phases can uniformly disperse throughout. So for doing that, I first need to cancel or tear the weight of the box, the machine, and once it has been teared, I want to take it out and put a little bit of this phase 1 here, on the surface of this, to ensure that it goes all the way to the top. We need to be a little careful while handling this. Okay, and in the other part, which is in this particular solution here, also a curing agent. Okay, so first of all we need to weigh this and find out how much this would be. So this happens to be about close to 30 grams. So we need exactly 3 grams of this other material to keep it going. And so as I told you that the chemical balance here measures the quantity of the PDMS, at least the silicone rubber part which we have put inside this small box, and then we have to mix the curing agent. But before doing that, one has to ensure that whatever mold you are using will release the PDMS after the heat curing action, etc. is over. So the idea here is that I would need to treat this with some kind of vapors or some kind of chemical which will formulate a monolayer on the surface of this material. PDMS otherwise is highly hydrophobic in nature. The contact angle is about 108 degrees. So one has to have a hydrophobic surface so that there is a mutual repelling action between the two, and there are no as such van der Waals forces which develop between the surface and the PDMS, and there should not be any stiction, particularly when you are pulling it out. That's the purpose of a release agent. When you talk in castings, you use powder on the walls of the mold so that the metal comes off without damaging or breaking the mold. In this case, breaking is not possible because the PDMS is a softer material, but yes, it has to be coated properly so that it should not be that the features entrap a part of the PDMS and it gets broken off, that resulting in a bad finished casting. So mold release is very, very important. So what we are going to do is to use a vacuum desiccator right about here, and we are going to use something called HMDS, which is commercially otherwise available in vials, and this material has to be handled very carefully. The HMDS is normally coming in a closed vial. It has to be taken to a fume hood, something like this, where you can break open the cap of the HMDS and transport the bottle all the way into the desiccator and then evacuate it. And before doing that, you ensure that you put this into the desiccator so that the environment given by the vapors sort of does a preliminary treatment of the surface by giving a small coating on the surface. So as you can see now, the processing of the vial is done. There is a vial inside which is broken cap, and the material that you want to coat with, that is the mold, everything is inside here in this particular desiccator. And there is a pipeline which goes into otherwise a evacuating system, small mechanical pump, and that takes care of sort of close to 10 to the power of minus 1 or minus 2 torr vacuum within this particular chamber. One reason why the vacuum is also engaged is that this material HMDS is highly volatile in nature, and the idea is that it should actually come and evacuate or come because of the negative vacuum pressure and formulate an environment over this surface, including the plastic box, the mold, etc., which is kept inside for a very long amount of time, so that there is a small layer. And in fact, you will see that the layer which is formulated will be visible as a small whitish layer on the top of this surface. So this process will take about 15 minutes, beyond which we will have to examine whether the mold is fully coated, and then if we feel that it is fully coated, we will go ahead and stop the process. Otherwise, we will have to again recoat it so that that small thin whitish layer can be seen on the surface of the mold. So this right here is a demonstration of how the oven functions. So there is a controller for this oven where there is a set value which you need to set for heat curing PDMS. PDMS, as you have seen before, has been mixed into two different parts, component A and B, curing agent and the silicone rubber, and you are heat curing it to a temperature of about 85 degrees Celsius for about 40 to 45 minutes, and this has to be very precisely controlled. Otherwise, if the temperature is higher, the plastic container, it might just warp and it might just deform and change the shape of the containing mold, which is really not desirable. So what we do is to preset the oven, as you are seeing here, at 85 degrees and wait for the oven to achieve a temperature all the way up to the set point value. As you can see in a little bit quick glance here, that the temperature is changing quite a bit, and basically the temperature, once it achieves the 85 degrees Celsius, you have to keep the oven in closed conditions so that the temperature is maintained at that particular level. Now, once we are sure that the temperature has been reached, the other important aspect is to take out the mold which has been cured prior to this or coated prior to this using the HMDS or the hexamethyl disilicane layer and a release agent layer. So what I am going to do is to sort of take out the mold from the evacuator and see the mold surface. Clearly it is indicative that there is a layer on the surface. So we pour the 10:1 ratio of the curing agent to the silicone primer from the other box that we had earlier taken provision for this purpose onto the box containing the mold. Okay, and so once this is thoroughly poured and the whole PDMS is transferred, it is a very viscous substance, as you are seeing, like molasses, and therefore it needs to, you have to really hold it for some time for the material to be completely loaded onto the other new box containing the mold. So once this is finished, you have to really check what is the level of the PDMS on and over the mold pasted on the surface of the box, because mind you, the mold height has now changed because of the thickness of the double sided tape which has been inserted below the box. So you have to actually see now what is the level of the PDMS on the box. If you are happy, there is another issue about setting up the evacuator again, because mind you, when you are actually trying to do this process of mixing agent, curing agent along with the silicone polymer, there is a issue of entrapment of bubbles and dissolved air which comes in. So that air has to be removed, because otherwise when it starts heat curing and there are convective currents within the medium, there is a tendency of these bubbles to formulate a two phase system, and bubbles in this manner, if they get entrapped into the cured silicon matrix, would have a lot of problems regarding optical visualization of the PDMS matrix. So we place this PDMS now on the vacuum desiccator and wait for a few minutes at high pump pressure for the desiccation action to sort of pull out all the air which is entrapped in the PDMS matrix. In the meantime, you also should check the conditions of this gravity fed convection oven, which has been sort of now stalled at about 85 degrees Celsius, and the way you normally handle is to actually keep a sort of elevated platform which is already pre-balanced, and there could be an issue of proper leveling of the mold box that you are eventually going to place into this oven. So normally it is pre-leveled by using a spirit level. Such ovens also have the possibility of tilting shelves, so therefore you can actually, using a spirit level in a crisscross manner, do both X and Y. In the X and Y direction, you can check whether they are completely leveled with respect to gravity, so that the overall PDMS surface can be flat. Now it is high time now that this desiccation has already happened or occurred, and bubbles must have come out of the solution. So we are going to replace, we are going to just sort of take out the mold box along with the PDMS on the top and see what is the condition of that mold box. You can see here that there are bubbles in a way coming off the surface of the PDMS, which actually is suggestive of that the dissolved air has really come out. Okay, so a few more minutes are needed so that you can individually burst these bubbles, and you have to see that over this mold really are there any bubbles or not. In this case, over the mold you have relatively a clean layer of PDMS which you can see, and so the idea is that once this has been formulated, you can put this into the oven in the level plate. There is a level plate here in the bottom corner, as you have seen. Okay, so you just put this over the level plate, and the same can be done with the shelves as illustrated earlier, so that the level of the PDMS over this mold is completely flat in the X and Y direction, okay, parallel to the gravity, and close the oven and wait for about 40 minutes till the PDMS actually achieves the necessary curing action. Because of the opening of this oven for loading and offloading, there is a sudden change in temperature, as you can see here. It again needs to go all the way to about 85 to 86 degrees Celsius, which it has now reached in the PIV control, and we have to wait for 45 minutes so that we can actually have a good cured sample of PDMS, which will later separate from the mold which has been formulated. You can see here actually the sample has come out after 45 minutes,